In this video, we want to look at rational functions. But before we do that, we want to refresh our memory on what a rational number is. And if you think of a rational number, think of this first part, ratio. And if you remember a ratio, another word for ratio is fraction. So when we talk about a rational number, we think of a number that's a fraction of integers specifically. So numbers like 2/3, -3/2, -4/5, 3/7. Those are rational numbers. Not something like pi or square root of 2. So what we want to look at today are rational functions. So if we think of the same thing, ratio, meaning fraction, it is a fraction of polynomials. So you're going to have a polynomial on the top and a polynomial on the bottom. And what we want to do with these is we want to look at graphing them. So we want to graph these, and we want to find what are called zeros, what are called asymptotes, and what are called intercepts. So first, let's talk about what is a rational function. All of these are examples of a fraction that is of polynomials. So we do not have things like the square root of x. We do not have things like 2 to the x. These are polynomials on the top and bottom, which many times means we can factor them. Okay. It also means we can easily solve the top and the bottom and find where there's 0. So these are what our rational functions are going to look like. And we want to be able to understand the graphs of these functions. So these are some of the characteristics of a rational function. The big thing that makes these look different is these horizontal and vertical asymptotes. Now, I have them dotted on here in green because they're not actually part of the graph. Only this black line up here, and if I was to use a kind of dotted pink, only these parts right here are actually part of the graph. The rest of the graph, the green lines, we just use to help. And the idea is that these graphs get closer and closer to our vertical and horizontal asymptotes, but never cross them. Now, it's also possible to get what's called a slant asymptote. And the slant asymptote, as you can see, is the graph, instead of being a horizontal line, they kind of curve up, like that. So we want to be able to find all these characteristics. Now, some things we've already talked about. The y-intercept is where it crosses the y-axis, and we've already talked about where it crosses the x-axis or the y-axis. We know x is 0. And at the x-intercept, where it crosses the x-axis, we know y is 0. So we've already talked about that before. So what we really want to look at today is how do we find these asymptotes to sketch the graph. So these are going to be our steps. The first step is we're going to find the domain. What makes the bottom 0? Okay. Because one, and I'll jump ahead here, down here are vertical asymptotes. Where we want to look for those is when the bottom is 0. So that's kind of similar to the domain. We then want to find the zeros or the roots or the x-intercepts. That's where the top is 0. So that's what we found already. We found where the bottom is 0, and we found where the top is 0. And then the third thing we want to do is we want to figure out what does the function equal when x is 0. That is our y-intercept. So we find all that information to help us graph this equation. And then finally we want to find our slant asymptote or horizontal asymptote. We kind of divide the bottom into the top. And then finally we're going to kind of use our calculator to help confirm that we got it all going right. So let's look at an example. X plus 2 over x minus 2. First, our domain. What can x not equal? Well, x cannot equal 2. That makes the bottom 0. Now, where's our x-intercepts? Remember, our x-intercepts is where the top is 0. So what makes the top 0? Well, that will be x equals -2. So our y-intercept is what happens if we make the x 0. So if we make the x 0 and we want to find what is f of 0, that is going to be 0 plus 2 over 0 minus 2, which is negative 1. Finally, the asymptotes. Our vertical asymptote is where the bottom is 0. So my vertical asymptote is at the line x equals 2. Now it's opposite of the domain. We'll see that in a second. In our horizontal asymptote, this is a little bit harder to find. To do this, if we look at our function, x plus 2 over x minus 2, if we go back, we're going to divide the bottom into the top. So we have to remember x minus 2 in 2x plus 2. We got to remember how to do long division from algebra 2. Now, this is not a huge thing. We don't have to do the whole thing. We got to do just one step. So the question is, what times x gives me x? And the answer is 1. And then we could continue on and do our long division. But I don't really care. That number right there is all I need. So my horizontal is y equals 1. So let's look at graphing this. We have x plus 2 divide by x minus 2. Let's do zoom 4 first, see what it looks like. Hard to see, so let's go zoom out, zoom 6. So notice what we have. Our vertical asymptote right here at 2. You can see we have our, let's bring this up here. Move this over here so we can see it. Our vertical asymptote is at 2. It doesn't cross there. Or horizontal asymptote is at 1. Doesn't cross there. My x-intercept, or my root, is at negative 2. It crosses right there. And my y-intercept is negative 1. It crosses right there. So if we wanted to sketch a graph of this with this information, not using the calculator, let's think about what we could do. We could put a few things on our graph. We could say, well, we got a x vertical intercept at 2. Get it closer to 2. And let me make that a little bigger so you can see it a little better. There we go. And we have a horizontal asymptote at 1. So there are our horizontal and our vertical asymptotes. We know that our graph has an x-intercept or a root at negative 2, which is right there. We know that it has a y-intercept of negative 1, which is right there. Now we know when we look at the graph that it really can't cross anything else. So we know that this comes here. Oh, sorry. I had this point in the wrong spot. There we go. Comes down like that. And then up here, it goes like that. Now we're not looking for exact points, because those exact points, you really need a calculator or some other way of doing it. But you can see we can get a really good estimate of what the graph looks like by doing that. Okay. Let's try another one. 3x plus 1, x plus 2. Our domain, x cannot be negative 2. Our zeros, roots, or intercepts, and what makes the top 0? And the top is 0 if you would say 3x plus 1 equals 0. Subtract 1, you get x is negative 1/3. The y-intercept is f of 0. So I put 0 in for x, and you can see really what that does is it just gets rid of all these x's. So that 0 is 1/2. Let me bring that back. And the asymptotes. So my vertical asymptote is just x equals -2. And my horizontal asymptote, I need to do some division. So I have x plus 2 divided into 3x plus 1. So what times x gives me 3x? It's 3, and then 3x. And I don't really care what the rest of that is. That number at the top is all I need. Y equals 3. So there's my information. Now let's see if we can graph it. So we have our vertical asymptote at -2. So I do a line at -2. My horizontal is at 3. So there's those. Now, at 0, it is at 1/2. That's my y-intercept. And my x-intercept is -1/3. That's right there. So my graph is going to come up like this. And then up here, it's going to be like that. That's my general shape of my graph. So let's check. 3x plus 1 divided by x plus 2. And I get that graph right there. And that looks pretty close to what we got over here. So you can see we can get a lot of this from the calculator. However, as our functions get more complicated, I'll come back to this in a second. As our functions get more complicated, this is harder to see. It's harder to tell directly from the calculator without using these rules. For example, here, what makes the bottom 0? Well, if I have 2t minus 3 is 0, my t, x, cannot be 3/2. So then my vertical asymptote is x equals 3/2. Now, intercepts, roots or intercept is where the top equals 0. So 2 squared minus 2 is 0. This is going to give me t squared is 1. So my answer here is going to be plus or minus 1. And if I want to find 0, once again, make everything 0, and I get 2/3. Last thing I need to do is I need to find my horizontal. So I take 2 minus 3 divided into 2t squared minus 2. And I say, well, what times 2t gives me 2t squared? Well, the answer is not a number. So because of that, I have no horizontal asymptote. And from what we've talked about before, this is actually a case where I get this slant asymptote, but we're not going to really worry about that. So we're just going to say there's none. So we were able to find where these vertical asymptotes were on this without having to rely on the graph. Because if we look at the graph, 2x squared minus 2, 2x minus 3. You can see we have this slant asymptote, but you can see here is my 2/3, here is my plus or minus 1. You can see all of those things that we found. We're not going to really worry about this line, this slant asymptote right here. We just say there's no horizontal asymptote. Okay. Now I want to go back and talk about this one. Because if we looked at this one, and we have t squared minus 1 over t minus 1, and we look at the graph, We say, well, there's no vertical asymptote. What happened to the vertical asymptote? Well, what happens on one like this is if we can factor out that number. If you have a factor that makes the bottom and the top 0, they cancel out and they create this hole in your graph. So you have no vertical asymptote. This is basically looks like the graph t plus 1, slope of 1, y-intercept of 1, and we say t cannot be 1 because we've canceled it out. So you always want to be able to look at if you can cancel these out, that there may be a hole in the graph. So if you look at something like this, your first thought is, well, let's factor out the top. Now once you factor out the top and you see there's no common factor, now you can go on and say your domain cannot be 1, your x-intercepts are 4 and -1, make the top 0. Your y-intercepts, if you put 0 in for x and all the x's, you get -4 over -1 is 4. Your vertical asymptote is x equals 1. If you divide the top into bottom, you can see that there is no horizontal asymptote. So if we try to graph this, we have x minus 4, x plus 1, divided by x minus 1. So I do not expect you to do, type something in wrong. Do not expect you to do this whole thing without a calculator. It's just we want to use the calculator to help us. And sometimes you have vertical asymptotes and things at points that are hard to tell. Are they at 1? Are they at 1/2? Are they at 3/4? So we can use the calculator to help find where these vertical asymptotes are at. And we are ready for the homework.